So let's start. Last week I created a couple of fixes to enable test-ready run search-based strategy test with Crimson, and the latest test result. I'm pasting the latest result in the chat window. So it's blocked by some failures in BlueStor, but I don't think it's related to BlueStor. I'm going to look into it this afternoon. And apart from it, I was reviewing Sam's PR to add the pin machinery to the LBA tree. And that's me. Tremaine.
Oh, okay. So I updated the PR according to the comments, and so could you please review it if it is. I assume that the extend map tree is stored in the onode block. So I will not store it in extend map tree. So when the onode catch the extent will be duplicated or something, and it will update the extend map tree. So each transaction can use its correct extend map tree route information. And next task, I rebase my code to Sam's LBA pin patch and found some problem. And Sam said it is decrease reference is missing. So I'm wait for Sam to update it. And then I can rebase on pin patch.
You don't actually need to bother. Just rebase on the pin patch. Just comment out the decref calls. I checked your unit test passes under those conditions. Your current patch doesn't build for me though, so do that stuff first.
But when I run the unit test, it failed because the pin content is
Yeah,
conflicted.
I commented out. If you simply comment out the decref calls, it'll be fine.
Oh, okay, I see.
So test with that for now, rebase on the LBA pin thing. I actually do have a fix for it, but I'd like a working version of your code so that I can uncomment it out and make sure that it works now. But I need a version that builds. Currently, it's not.
So I can rebase on your patch currently so that it works if I comment out the decrease reference?
No, because I haven't pushed it yet. Just
okay.
Comment out the decref reference calls. Or I'll push this version and I'll let you know which branch to borrow. I don't know for sure that it works though because I don't have your branch to test.
Yeah, okay.
It doesn't currently build.
So when you push merge in, I will rebase and provide patch. I can test by my local machine. And then next, I'm working on the map tree layout operation currently. So that's all, Kafu.
Thank you, Tremaine. And Sam.
Well, actually, you had a bunch of unaddressed comments on your PR from me still.
Pardon?
You still had unaddressed comments on your PR. For instance, you haven't fixed LADR, LET.
LET. Oh, that's because the KV fixed KV node layout needs some constant operation. So Ceph LE64 doesn't provide that one. So I provided the error address.
You can't do that. I told you in the patch why you can't do that in the PR.
Yeah, I changed it to modify it for the ending.
It looks like it's a UN64 right now. Was I misunderstanding your code?
Oh, okay. Did you add new comments for it?
I'm looking at it right now. Sure. But I do not think you should need to change it, to be honest. You should be able to leave it the same way it was before.
So, I can understand. Do you mean I need to use the Ceph 64, Ceph LE64?
No, I think my definition for LADR LET should be fine. I do not think you should have to change it. You will have to create a wrapper struct of your own to wrap it.
Oh, so but address LET, just used Ceph LE64 originally.
Yes, but you changed the LET or LET type in
yes, that's
SeaStor
because
type.8.
Ceph LE64. So in the KV fixed KV node layout, they need the input parameter is constant, but the Ceph LE64 doesn't provide that interface. So you see the difference as I add a.
You mean it doesn't have a const constructor?
Yes.
Just use the init Ceph LE64 directly.
But
you're going to have to provide your own wrapper struct for the meta, okay?
Then
I'm not actually sure what problem you're running into, to be honest. I got it to build with the other version.
If the error address in the value part, so when they set value in fixed KV node layout, set the value, there is a problem. They need the input parameter is the constant. If the error address in the K is no problem.
Well, in that case, you can't use LET or T as the internal type for LET or LET. And you need to fix the other users elsewhere in the code base.
So you mean I fixed the KV node layout?
No, Chunmei, I'm saying you broke the build. I can't build with this because you broke a bunch of other code.
Oh, okay.
So I'm not quite sure what problem you ran into. If you want to, you can send an email with a question, but at least this version I can't seem to get to build.
What base you used?
Your current branch.
My current branch? But it works on my machine. Okay.
Well, maybe. Whip SeaStor extent map.
Pardon? What's this?
Will you Chunmei / or SeaStor extent map tree?
What's the branch name in the case?
That's the branch name, SeaStor extent map tree.
Okay.
Yeah, SeaStor extent map tree.
I'll give it another look. Maybe I'm misunderstanding.
Okay.
Sam? Yep. I'm adding support for deckref properly so that it will correctly retire the extent and, get rid of it out of the cache. I have what I think is a working version, and then I'm back to working on dirty extent write out, etc. That's it.
Okay. Sam, regarding to your PR, I think it's I got your point, and what is missing is just to add a little bit more comment regarding to why we need to ping. Probably it's a
I think I did.
But okay.
I pushed a version earlier today. You can have a look if you need more. Let me know. But all we're doing here is making sure that when we do dirty write out, we don't have to do a bunch of extra reads. Very wasteful.
Yes, I got it. That's a pain of the rendering tree, I guess.
No, it's actually true of basically every B-tree-based metadata system. You kind of always want to do this. There's just never a reason not to.
Okay. But I just put the branch like 20 minutes or so ago. Probably I can check it later.
Let me see if it worked. Hang on. It was just one more paragraph in that header file.
Okay, I'll check out later. But I think it's a good code. I was just not quite understand why we need to ping, but I think I figured out now with your help.
I mean, we don't need to. We can not do it, but the performance would be really bad. This is an extremely good, caching heuristic. There's reason not to.
But probably we could worry a little bit later because it's now mandatory to ping all the parents.
Yeah, it's extremely annoying to retrofit the data structures to do this. So I'm doing it now. All the internal in-memory data structures need to be able to do this efficiently because you have to mess with it all the time. So no, I actually do want to do it now. I understand that, strictly speaking, I'm not super worried about performance now, but we will need this for sure.
I understand, but Sam, my concern is that you make this mandatory to add to ping all the parent of a node in the cache, but but we don't have a way to evict a node, a parent, for example, out of the cache.
That's correct, because you don't evict the metadata nodes, you evict the leaf nodes.
Right.
Right.
We can. Yes, because if I understand correctly, it's all about caching the caching the parents.
Yeah.
But when it comes to cache, we always need to have a machinery to evict the not used elements or nodes.
Right. So the LRU would operate on the children. Once the child that's pinning it goes away, the pin goes away too.
I got your point. Thank you.
So in other words, cache pressure applies to the things we actually want to cache. We don't actually want to cache the LBA nodes at all. The internal nodes we only keep in cache if there's a child in cache under them. There's no other reason to do it. And the reason we keep them in cache is that you'll notice this implementation doesn't have a second logical address lookup. That is the ladder cache. There isn't another one.
Okay, I'm good. Thank you.
Cool.
Johan.
Last week, I was developing the interruptible aerator future, during which I found that maybe a series of aerator version of future facilities like parallel for each or when all succeed, that needs to be implemented. So I'm now working on that part, and that's all for me.
So if I understand correctly, you are trying to replicate the primitive offered by SeaStor, just like what we did in aerator. Okay.
Yeah, I need to add those primitives so that I can replace aerator future, replace SeaStor future with aerator future on the I/O execution path.
So your machinery is embedded in the aerator, right? Instead of embedding your own.
Yes.
Okay, that's a relief. Okay, thank you. Yixin?
Yeah, I think I'm working on a similar implementation like Sam currently is working on. So I'm working on to implement a tracking facility, so that if a tree look up an old node, if someone else hold the return cursor, the old node will be available, kept available and kept tracked to the
you can't.
Pointer. Sorry?
Wait, do you mean you're trying to keep references to an extent after the transaction ends?
No, it's inside the transaction.
Okay, cool.
Yeah, that's me. So it's
keep in mind the transaction itself is going to keep any cache extents any extent you've touched, the transaction will keep in memory. So the correct answer normally will be to redo the lookup if you need to get to that node again. It won't cause more I/O. Okay.
Okay.
So you should, I mean, it's okay to hold a reference as long as it's within the same transaction, but you shouldn't need to.
Actually, I don't get you. Every node you touch in the transaction is cached in the cache of the transaction, so it's a.
Yes, but it's held. Well, yes.
I think there's another reason that if in that transaction, if you need to access that old node in the extent after an asynchronous operation, and if you hold the cursor of that old node, that old node pointer will be kept updated with less effort, because if you want to access that old node again in another continuation,
in the same
yeah, that's fine. Under those conditions, yes. Under those conditions, yes, you probably can do it. Just be really, really careful not to hold references between transactions.
Yes. I think I understand that requirement.
Cool.
But could you say it again? What's the problem you are trying to takeaways?
So it's just to keep track of the cursor to the O node in the leaf extent if you need to keep track on it in across the continuations, because
across the continuation, but in the same transaction or across transactions.
Yeah, in the same transaction. In the same transaction.
Okay. Cool.
So if you hold that cursor will be always valid to point to the
that's true.
The O node.
Yeah, I think so.
Along with the split and the merge, and so on, the operations to the tree.
I mean, as long as you're really careful that if you do split the node you're pointing at, you update the pointers.
Yeah, yes.
Why a cursor, though? Is it that you expect to relook up the same O node? Or you just need to keep a pointer at the page it was in? That's all.
You keep the pointer of the O node stored inside the extent.
In case you need to mutate it later? Okay,
Yeah,
that makes sense.
Mm-hmm.
How do you plan on handling the possibility that another portion of your code causes a split on that node? How will you find all of the previous references?
The references are actually kept inside the node. The in-memory node structure. That node structure is inside the transaction.
How can you be sure that when the transaction ends, those nodes won't be seen by another transaction later?
That's interesting, because the reference is the reverse. So it's the cursor holding the leaf node, the reference of the leaf node, and the leaf node holding the reference of the internal node until the root node. So if we
that's what I'm talking
all
about.
The cursors, that the entire structure will be freed.
I'm not worried about it creating. No, it's not that. It's that. So let's say your leaf node has a reference to extent E, right?
Yes.
Oh, but but in memory. So the trouble is that if I relocate E because I did a compaction or something, then the in-memory structure you're pointing at is now invalid.
Yes.
It'll be in memory still, but so it's not invalid access, but it won't be the same extent. I won't know about that structure.
The leaf node understands all the cursors attached to it.
But so I'm saying my code doesn't. The transaction manager code doesn't know anything about these pointers. It has no way of fixing them.
So that's implemented in the O node leaf node.
How?
It's not related to anything about.
No, Yingzhen, it is. So the cache nodes that sit in memory, like at all time. So I could, like, every time I do let's say it's dirty and I do a write out, or I move it from one portion of the disk to another, I create a new in-memory node. So how will things that pointed at the old one now know to point at the new one?
So you mean, okay, so do you mean even if I holding the reference of the extent, it's...
That's correct. It'll be valid. It'll still exist, but it'll still be allocated memory, but it'll be marked invalid and it won't be used.
Well, you could check the status of extent. If it's invalid, you need to look at it again.
No. I don't want that. I'd rather he just redo the lookup by ladder. The whole point of keeping the ladder trees in memory is that
the address is kept the same, right? So I can just reread the extent from the address.
Yeah, I don't want you checking the status though. It leaks way too much information from the next layer down.
Okay.
And I just don't want to deal with it. We would make it very difficult to change anything about Transaction Manager.
Okay.
So I would rather you just kept the ladder T and just redo the lookup each time.
Across the transaction. When a new transaction.
Yeah, but that also means you can't stash a pointer from one node to another in a node. That's the really important part. Don't do that.
But yes, that pointer is it's like a smart, because when
not
doing
smart
split,
enough. I haven't written code that knows how to update that pointer. I promise.
mean, when the leaf is split, that pointer is being invalidated. So when next time
in your code, yes.
Yes.
I'm not talking about split and merge. Your code
Yes,
knows how to deal with it. Mine does not. My code can take any node you have, copy it to another location, and not tell your code about it at all.
Okay, I think I can handle it correctly in that case, because the node knows the address.
The L adder T, yes. Is that what you mean?
Yes,
Logic
the node.
address.
Yeah,
the
so
node,
if you just redo the lookup by L adder T, that'll work fine.
Yes. Yes, that's my meaning.
Okay, great. Just don't maintain an actual pointer to a location in memory. That's the only thing I don't want. Okay, cool.
Okay.
I'm sorry. I thought you meant you were stashing a cursor to the actual cached extent ref. That would be dangerous. But stashing the logical address is totally fine. That's what they're for. Sorry about that.
That's also my impression. Okay. Anything else? Okay, thank you guys, and talk later. Have a good one. Bye.
Later.
You.
Yeah.